Important mic check. Are we working? We're live. Fantastic. It's my pleasure to welcome you here this evening to this Leeds Alumni Voices 2024 event. We have an extremely exciting evening for you all. First of all, I'd like to introduce myself. My name is Anna Hogg. I'm a Professor of Earth Observation in the School of Earth and Environment here at the University of Leeds. And I'm also founder of Space Hub Yorkshire, which is a regional space cluster funded by the UK Space Agency. And you may have spoken to my colleagues in the foyer earlier this evening when you were having your welcome drinks. It's fantastic to be working in a university like Leeds, where we have such a fantastic expertise in all things to do with space, whether it's materials science, Earth observation and studying how the Earth is changing in response to climate change. You can find an expert in that field here at this university. What an awesome place to work. So on behalf of the University of Leeds advancement team, we've organised this evening, and the advancement team is crucial to our ecosystem here at Leeds. With our alumni, we have a network of over 340,000 alumni, and this is a great way for us to stay connected with you all through events like this, where we can come together around a particular topic. There's a photographer present, but they'll only be photographing those on the stage, so I hope that's okay with you all. And there are no fire alarms planned, so if you do hear a fire alarm, please exit the building. And that's my air hostess moment. So I'd now like to introduce you to our guests this evening. So first of all, Mark Dorey is the Assistant Director of Communications Engagement here at the University of Leeds, so welcome, Mark. And most importantly, our distinguished guest, Matthias Maurer, who is here as a returning alumni of the University of Leeds. So you all know why you're here tonight, but I'll provide a little summary of facts that you might not have discovered. Matthias is a German ESA astronaut with the European Space Agency, and his science background is that he's a materials scientist. Matthias has studied materials science in a number of different countries and at a number of different universities, including Germany, France, Leeds, importantly, and Barcelona. He completed his PhD thesis in 2004 over in Germany, where he studied lightweight composites made of aluminium foam with thermally sprayed coatings, very relevant for space travel. And he applied to the European Space Agency as an astronaut in 2008. The competition was tough. There was over 8,500 other candidates that Matthias had to beat in order to get this prestigious position. But quite rightly, he was welcomed into the European Space Agency's astronaut corps later on. He launched into space on the 10th of November 2021, a challenging year for all of us, but an extra special one for you. And finally came back down to Earth on the 6th of May 2022 after spending 175 days in space. What a life-changing experience. So without further ado, I'll hand over to the speakers this evening who will take it away. Thank you very much.
Thank you, Anna, and once again, welcome back to Earth, Matthias, and more specifically, welcome back to Leeds. It's great to have you with us. We spoke just before you launched, and I'm really excited this evening to ask you about all that's happened since we last spoke. And we've also received some brilliant questions from our audience here in the room and audience online as well, so we'll come to those as well. But just to help us set the scene and transport us up to the outermost layers of Earth's atmosphere, we're going to watch a short video clip together about your mission, Cosmic Kiss. Some amazing stats there, Matthias. You became the 600th person to go into space. Like Anna said, you spent 175 days on the ISS. Whilst you were there, it made 2,832 orbits of the Earth, and you travelled over, I'm going to get this wrong, but 120 million kilometres as well. But I'd like to start our conversation this evening by taking you back to the 23rd of March 2022, when you became the 12th ESA astronaut to conduct a spacewalk. You told us before you left about your dream of taking that spacewalk and looking back at Earth from space. So tell us, how was that experience for you?
Yeah, first of all, good evening. Thanks for having me here. It's nice to be back here in Leeds, where it all started, where the first step of my space dream came true. I learned how to fly a glider plane here in Leeds, and that was triggering the dream to fly even further, to see to see Earth from space. So as an astronaut, we have several dreams. One of the dreams is to ride a rocket into space. And the second dream is to open the door of the space station and to step out into the space and walk around the space station. And then you have only 3 or 4 millimeters of plexiglass in front of your eyes that separates you from the vacuum of space, a place where humans cannot live or survive, and inside your small spaceship, the spacesuit. It's an incredible moment. It's a lot goes on in your brain, and it's basically your brain that wants you to stop and says don't step outside, don't step outside, stay inside. Here you're safe. You open the door, and then you see between your feet and Brazil, which was gliding under us at that moment, 400 kilometers of nothing. And your brain tells you, you're falling, and it's true, you're falling, but you're falling half a year around planet Earth. The entire principle of being weightlessness, in weightlessness, is because you're falling all the time. But during the training, you learn how to cope with it. And so you trust your training, and you go outside, and I told myself, okay, don't look down. I don't want to start this kind of nervousness, this attack of a little bit of panic, and to grab hold and not move anymore. It's some astronauts had this feeling before, and they you freeze outside and you're not able to work anymore. So I said okay, I just look at the space station, and that gives me confidence, and then we will start working and everything will be fine. That's what I thought. But
you said everything was going to be fine. But there were some challenges with that space walk. You had challenges with your helmet as you started, and some challenges later on with water. Do you just want to talk to us about those challenges and how you were able to overcome them?
Yes. So, my plan was not to look down, because I know I had 6 or 7 hours ahead of me and a lot of walking across the space station, and you need all the energy in your arms and your hands, because it's tiring to move this spacesuit. We have 0.3 bar inside, so every time I move my hands, it's like squashing or squeezing a tennis ball, and you only have so much energy left. So I thought, okay, we take it slowly. And when my colleague Raja stepped outside, he all the stuff that we had on the inside of our airlock, it is attached to the station with tethers, small tethers, so it doesn't float out and drifts into space. So somehow he caught one of these tethers, and it activated his the backpack has a kind of a rescue system. So in case that you lose contact with the space station, you can activate it, and there's a joystick, and you can fly back to the station. So you have exactly 30 seconds of fuel, and then you can fly back, or try to fly back if you manage. So this system got activated, and I thought, ooh, now I need to fold this one back inside. And it's already difficult to do it without space gloves. But with the gloves, it's quite challenging. So I thought, no, this is not good, not a good start. But okay, I managed to put everything back in, and I was a bit too excited about being successful. So I put the bag that came out accidentally back in, and I grabbed the one that needed to be outside. And I moved a little bit too quick, and I got trapped now in a tether. And this tether wrapped around my cameras on my helmet, and it pulled the entire assembly off. So basically, all the stuff, all the gear that I had on my helmet cameras, lights, and all this stuff. It suddenly was floating next to me, and I was like, no. So it's like, all this stuff can happen, and it happens very often, but these two problems within the first 15 minutes was not a good start.
It sounds like a scene from the film Gravity that you're describing.
So it took us exactly 1 hour outside of the space station to recover and to be in the configuration where we should have been in the first minute.
And then the issue with the water?
Well, before we come to the water, I had some more issues.
More challenges.
In between. Yes. So you walk on the outside, and this EVA, we call it extravehicular activity, it's quite challenging because my colleague Raja, he was on the robotic arm, he had his job to do, and NASA sent me around the different modules. I went to the European module to fix something, then to the Japanese module to fix another item, and then back to the US modules, and I had to go back and forth to the airlock, grab stuff. And at a certain point in time, I was a little bit too quick, and I did the wrong movement, so I turned left when I should have turned right, or the other way around, and so I wrapped myself in my safety tether. And I was like trapped like in a spider net, and I thought like, oop, and I couldn't move anymore, and this stuff, it's you're out there, and you're alone, and you feel like I cannot move, and so then I needed to say the magic sentence, Houston, I got a problem. Yeah, so luckily they had a good camera view on me, and later on my crew surgeon told me they were all jumping in mission control, and so like turn left, turn right, turn up, and then in the end I got all the instructions, and within 2 or 3 minutes I could wrap myself out of my safety tether and continue. And when I thought like, okay, this day was already exciting enough, at the very last moments I suddenly had water in my helmet, and you might now wonder why there's water in the helmet. So we have in our life support system, we have cooling water. And the cooling water is because you're sweating inside the spacesuit, and then the wet air gets dried again, the water gets pulled out by a system. And also you have an ice pack on the back, because you have the heat gets rejected into space by forming an ice layer on the outside. So there's water in the system. And in the past we had an issue where one of my colleagues, he had 1.5 liters of water inside the helmet. So basically all over his face was water, and there was the risk that he was drowning in space. And that was a scary, scary moment for him. And NASA took it very seriously and fixed the spacesuit. There was some microbial growth inside that blocked some valves. And ever since, when NASA hears the word "there's water in the helmet," they immediately they reacted. And so the last time that happened, like more than 10 years ago. And then in 2015, Tim Peake was out in space with his colleague Tim Copra, and Tim Copra had also water in the helmet. And that was the last time this happened. And NASA thought like they had fixed the issue, and now there was me. Like, oh, is this water in my helmet? And in the end, it was already when I was returning inside. Yeah. But okay, I had so many incidents, what you usually only have in 4 or 5 EVAs, I had all in one. But we made it. We managed to implement all activities that we had on our schedule. Yeah,
but slightly more dramatic day than you were anticipating from the sounds of things.
Definitely is, but it's. I also, in hindsight, it's the absolute best day I had up there. Yeah. And when people ask me, like, how did you feel like walking in space? The only comparison I have is like Alice in Wonderland. I fell down the well, and it's like suddenly I was in this bizarre new world.
Yeah, that's amazing. Thanks for describing that to us. Just winding back a couple of decades from the experience you've just described, could you tell us a little bit about your journey to become an astronaut? Was that always the dream for you?
No, actually, my dream was flying a plane. So I come from a countryside in Germany, close to Luxembourg, and I grew up there during the Cold War. So like Ramstein, maybe some people of you know, it's the largest US air base outside of the US. It's just 50 kilometers away. And basically all the dogfights that they were doing there, training and practicing, that was above our house, I had the feeling. and we had even two of these jets crash landing in our village, and so like independent incidents, so not in one. So, but I thought it's cool. These pilots are cool guys, and they fly up there and super fast, and they see the world from a third dimension. And so, as a kid, I wanted to become a pilot. Yeah. And when I was here in Leeds, and I learned that the student unit offers gliding lessons, and I thought, like, wow. So I signed up, and that's where I started my piloting career.
That's amazing. So, like Anna explained, you came to West Yorkshire back in 1993 to study materials sciences on an Erasmus program. Just tell us a little bit about what you can remember about studying in the city. You were talking earlier to me about the housemates that you've still got friendships with now years later. So, tell us a little bit about your time in Leeds.
I was in 92. I moved over here. I applied in 4 different universities in the UK because I thought I studied material science engineering, but I figured out that my English is not good enough, and as an engineer, you want to speak good English. So I decided I come up here to combine studies, material science, and learning English. And I was super lucky to have excellent flatmates. So we lived in Kelso Road, just Leeds 2. Yeah. And we had 2 Canadians and 4 British, for English guys in our house. And I still have contact with 2 of my Brit friends, one of the Canadians. And actually, on the weekend, I will see one of the other British guys that I haven't met for 31 years now. Yeah, it's going to be nice.
That's amazing. And
2 of them came actually to my launch.
Brilliant.
Yeah.
Wow.
Yeah.
That's incredible. And you've spent time today with some of our current students as well. How's that experience been for you, being back on campus and being around
It's good. It's good. And I mean, it's so exciting. What they presented to me, it seems like they have so much more knowledge than what I had at that time, and all the technology. And so I envy them for having this nice time ahead of them. Yeah.
And after Leeds, you went on to study at a few different other universities around the world. You studied in France, Spain, and South America. I just wonder, reflecting on your time in Leeds and your time studying at those universities, how did that equip you to ultimately the skills you need to be a successful astronaut?
You see, Leeds kind of triggered something to me. It's like, it was the very first time that I was away from home, from my home country. Mm-hmm. So I was a foreigner, and I had the chance to learn not only the subject that I was studying, but also a language, to look into a different culture. And that I felt like that is so enriching. And I thought, I don't want to stop here. I want to continue this journey. I want to have more. Kind of it's addictive studying abroad. Yeah. And exactly at that time, my university started a multinational course in material science. And so I thought, wow, this is a chance to continue. Yeah. And so I asked, and I was in a kind of a panic, saying okay, they know that I was already abroad, and probably they want to be fair and don't want to give me another year abroad to be fair with other students. So I wrote a nice application letter, and I made a lot of effort, and I thought maybe I can convince them. And when I got it, I was super happy and super excited. I showed up in France, and guess what? I was the only student who applied. It's unbelievable. I mean, it's like German students want to study English in an English-speaking country, but nobody wants to go to France. And so we had 5 fully financed places, and I was the only one who applied. It's still there. Yeah.
And following your graduation, your work and your career as a scientist, I just wonder, take us from that to then that process of applying to become an astronaut. There was quite a gap between that application.
Yeah, so after my studies, I traveled also a bit, and I believe that learning more about different cultures also made me curious to see and learn more about the world. So I did internships in Latin America, and after my studies also in South Korea. And I thought okay, I always was thinking, okay, maybe university career could be something for me. And I started my PhD. And after the PhD, I thought I wanted to go on a round the world trip. So I spent 1 year before I I finally started to work. But okay, I felt like all this was well invested time. And I worked in a company that that produces blood filters. So, and it's materials science, also with medicine, because I didn't do a military service, but a kind of a civil service as an ambulance driver. So medicine was always something that fascinated me. Medicine, material science, that was this job then. One evening I came back home, switched on the television, and there on the news it says, ESA is looking for new astronauts. And I thought, like, wow, this immediately triggered something in my brain. I felt like my idea from flying, looking down on planet Earth, and like this fascination of going even further out. As a kid, I saw on television that space shuttle flew to space, and I thought, like, these must all be superhumans out there. And as a kid, I never dared to dream this dream, because I thought, like, this is so outlandish, this is never for me. So, but then on this moment when I saw on the news ESA is looking for astronauts, I thought, like, okay, now these astronauts are not test pilots anymore. They are scientists. I'm a scientist. At least I considered myself a scientist at that time. They are engineers who work with the best technology. And they are working in international teams. And here I am. It's like having studied in different countries. I thought, this could actually be it. And when I looked at what kind of science are they doing in space, there's a lot of material science there. There's also life sciences, and so combined with my medical stuff, and fluid science, what I did in my medical job there. So actually I covered quite a bit of it, and I thought, like, okay, it's like, I'll give it a try. Yeah. And then there was 1 year of selection process. And after this 1 year selection process, I arrived in Paris, and I was being told, like, there are 10 people who passed all tests. So all these 10 people can be astronauts. Matthias, you're one of them. But then I was also told, ESA only has 6 tickets. And Matthias, you will never be an astronaut. That's what the boss told me. And I can tell you, after working so hard, getting so close to your dream, you actually believe you're there. But then this was an abyss. Like, you feel like, okay, now I'm falling, and all these dreams suddenly disintegrate. But then the boss offered me a chance. He said, like, look, you 4 guys, you did a tremendous job. We would like to have you for ESA. ESA is a cool company, a cool agency. We're doing, like, really cool stuff. Come and work for us. My 3 colleagues said, like, no, either astronaut or nothing. I said, like, I'd join you. I joined the team. And, well, then 6 years later, he came and said, like, I remember the time when you wanted to become an astronaut. It happens that I have 1 more ticket. Are you still interested? So that was my journey.
And what kept you motivated during that time? You said you'd suffered that, I suppose, rejection, but...
Yeah, I think it was twofold. So one part is really like a personal one. While I was being in the selection process, you know, you're there, you have medical tests, a lot of medical tests, you have all the screenings. At the same time, I had a good friend of mine. He was a really sporty guy, and he trained me, and he said, like, you need to run faster, you need to do this exercises, and to be strong. And so that friend of mine suddenly had a health issue. And while I was in my medical test, he was also in his medical test. And so in the end, he had a brain cancer, and he died. And so that, like, at the end, like, I realized, look, what's really important is that you're healthy and alive. Yeah. And then so that grounded me after this loss. This loss of chance, I should say. And the job that I was offered gave me also a huge chance to do a lot, like to actually bring in a lot of what I like, and to do some evolution on the European Astronaut Center. So it was the time when we started cooperating with China, and so I established this cooperation. I also laid the foundation of our new moon training facility, by triggering some stuff. And so I had the impression I could actually do something to improve like Europe's ambitions in human spaceflight. Yeah. And it was helpful to be told that like you will never be an astronaut, because I actually had it off. It was off my radar. You cannot do a job so close to astronauts while being miserable and always in your head like asking yourself like, why should I carry your luggage and you fly to space while I pass the same test? So then you would be in the wrong place.
Yeah. And then your dream did become reality. You did then become an astronaut. Tell us a little bit about the mission, Cosmic Kiss. It's the badge that you've got on your jacket there. Tell us about the aims of that mission and your role as a scientist. What were you most excited about?
Yes, so people very often ask me, like, why do we fly to space? Why are we doing this? And one answer is, okay, we do science in space. Another answer is like every euro invested into space creates 2 euros of benefit. And but okay, tell this to your children, and they will not be excited. I think the real answer is because we humans, we are curious. We want to understand. We want to do stuff that we think is possible, or like seems to be impossible. But if you look at the problem and you dissect it into small little pieces, then you can like actually like solve the issue and do stuff and learn stuff. And I was especially inspired by kind of the Nebra sky disk. It's an artifact that was found in Germany some 15 years ago, and it's 4,000 years old. It's the oldest depiction of the night sky. It looks a little bit like my patch, so I took the inspiration from that one. And being 4,000 years old, and looking at what this disk already is able to do, it's kind of like a calendar function. And so I understood that the people who made this, they had the same questions that we have today. They looked into the night sky and they wondered, what's out there? How does it work? Like we're here on planet Earth. How did like all this begin? And how's our journey to continue? And is there maybe another place like ours out there? So this inspires me, and I think these are the real questions. We wanna understand all this, and we wanna know our place in the universe.
Some big questions there. So, Cosmic Kiss, it's a reality. Tell us about how you prepared for that mission. Again, international collaboration comes a lot into that story as well.
Yeah. So I named my mission Cosmic Kiss because it's a declaration of love to space. And in the word kiss, there's also the ISS. And so it's like, for ESA, we always play with this stuff. Yeah. The international cooperation. So when you fly to the International Space Station, you need to go to the US, to Russia, you need to go to Japan, to Canada, because all these are partners of the European Space Agency, and everybody provides some hardware, some modules, some technology to this international cooperation. And you fly to this country to learn their assets. For example, you go to Canada and you learn how to fly, we say like to fly the robotic arm, how to work with it. The robotic arm is needed because we get resupply missions that comes in a capsule. And this capsule, some of them don't dock to the station. No, they just fly along the ISS. You need to catch them. And so you better train for this, otherwise your food disappears. Sometimes we also do a spacewalk. And one of the colleagues needs to go to a place where you cannot really crawl to. So we put them on the tip of the robotic arm, and then a colleague from the inside flies the colleague on the outside to the place where he or she needs to work. Yeah. So it's a very challenging, very demanding task, because you don't want to slam your body into the space structure. Yeah, so that's for Canada. Japan has a module, Europe has a module, Russia and the US have several modules. And then you also need to learn how the rocket works and the capsule works. And in my case, I flew with a SpaceX, a Falcon 9 rocket in a Dragon capsule. So that's why I spent some time also in California.
So you mentioned the Dragon there. Just take us to that time on Thursday, the 11th of November 2021, where you sat aboard after all those years of training, that incredible journey that you've just described. How did you feel as you're in that moment, given that, like you said at the start, that was one of your dreams as an astronaut?
Yeah, so you've seen it before in the video clip when we walked into this capsule, and it's a nice capsule. It's clean, it's modern, and it's spacious. And actually, it's like sitting in there is almost like sitting in business class, except that you have no service passing by serving you some meal. Yeah, you're in there, and it was not the first time that I sat inside this capsule, because our actual launch happened 3 weeks after the initial planned date for launch. So we had bad weather, then we had some of us got sick and we needed to wait, and then again the landing weather wasn't good, and then they decided to bring back the crew that was on space before we fly up. So in the end it took three weeks, and on that morning it was raining cats and dogs, and I thought, like, today we're not going to fly. And I only started believing it when the countdown started, like 10, 9, like, are we really going? And then suddenly the machine, like, it starts, and you get a push in your back, and it slams you forward, and it's super aggressive, this rocket, and you're a bit scared. You think, like, ooh, am I prepared for this mission? Yeah. But then it's too late to step out. So, and it takes 8.5 minutes of full acceleration while you're pressed into your seats. After 2.5 minutes, the first stage of the rocket switches off, and suddenly you're floating in zero gravity. You're already, after these 2 minutes, 50 seconds, you're already like almost 100 kilometers high. So you're already an astronaut, because like starting 100 kilometers, you're a real astronaut. Before, you're not. And and then again, 5 more minutes on the second stage, and then you're in space. You're traveling at 28,000 kilometers per hour. Yeah. And it feels like just like lying in bed. You're floating. It's super, super quiet, super nice.
Yeah. And that was obviously just one day. You then spent 175 days aboard the International Space Station. Just tell us, if there was a typical day in space, what did that look like for you, Matthias?
Yeah, so it took us 1 day to get to the station, then 175 days over there, and 1 day again to come back. You can go faster, or shorter in time, not faster, because the same speed. Because the Russian colleagues, they fly in the meantime in 3 hours to the station. Yeah, but that only is possible if you launch in exactly the moment when the ISS is passing exactly over the launch site. And there's so much traffic going on in Florida, so that SpaceX launches basically every 3 days, satellite missions, crewed missions, so that, okay, if you're not exactly passing over, then it takes a little bit longer to catch up with the station. In space, once you get there, the first 2 or 3 days, you feel like you don't feel well. You feel kind of like space sick is in the worst of all cases. In my case, it was like feeling like a hangover, like Leeds party nights the next morning.
We can all relate.
Yeah, just without the alcohol, just the negative side of it. And you start working. And in the beginning, you need to adapt to the new 3D environment. So you start working, you have your tools, and you put your tools somewhere, and if you don't put them properly, they just start drifting away, floating away. That's why everything has Velcro strips, and so we attach it to somewhere. But then, nevertheless, you move also while you're up there working, and it's so bizarre. You put your wrench down there, and you float, and suddenly you look at your wrench from a different angle. You don't recognize that's the wrench. You're looking for your tools, and sometimes it happened to me that I had to ask colleagues, "Have you seen my wrench?" And they're like, "That's over there." It's like, oh, "Okay, yeah." So you're slow in the beginning. You're slow. You're not efficient. You have a space brain. That's what we call it. So that takes a few days. In the beginning, I also read procedures that I had read before that I fully understood. Now in space, I read word by word. I understand every single word, but I don't understand the meaning. So it's like, it was interesting to see how your brain can slow down It's just because it needed time to adapt.
And once you've acclimatized, you're there, of course, to perform a number of scientific experiments, I think over 150 for this particular mission. Just talk to us just briefly about some of the
Yes.
work that you were doing whilst you were there.
Yeah. So our working week is from Monday to Friday, from 7:30 in the morning till 7:30 in the evening. In the meantime, in the middle of the day, we have 1 hour of lunch break. And we have 2.5 hours of sports. So 1 hour for cardio, 1.5 hours for sports, for muscle training. And the rest of the day, we do experiments and space station maintenance. And space station maintenance can be you need to fix the toilet, because that's important, or other stuff. And the experiments that we do have a lot to do with material science engineering. Yeah. So, for example, I had an experiment which was called touching surfaces. I was up there during COVID times. Sometimes in a pandemic, you transmit your germs to another person. It can be via the air, but it can also be via a surface. So I touch something, and half an hour you come, you touch the surface, and you get my germs without even knowing it. Yeah. So that special material that was developed was a kind of antibacterial surface. So it was supposed to kill everything that was left as a living organism on the surface. In space, we wanted to test this one because bacteria, viruses, they mutate much faster in space. Due to the space radiation environment, also to zero gravity, and at the same time, the astronaut immune system is weaker in space than on the ground. So it's very important for us to have a good understanding of what kind of bacterial growth we have inside the space station. And so this was a mix of a material and medical experiment. I also had to mix concrete in space. I had to melt metals. I had to do bioprinting. A lot of sensors stuff, that doing sports while having a smart T-shirt, like breathing gas analysis, core temperature measurements, because the temperature distribution in space is different in the human body. Lots of stuff.
You mentioned there some of the physical activity you were doing. How did you find adapting physically and mentally to some of the challenges that presented themselves to you during that period in space?
Yeah, so the adaptation phase in the beginning took a bit, but NASA knows this. So the first 2 or 3 days, we have almost no activity. The first 2 weeks, you get 20-30% more working time allocated for the same activity. So every activity is measured and prepared on the ground. So basically, a good astronaut can do this activity in 75 minutes. Then in the first 2 weeks, you get 20% extra time of that one, but later on you need to manage it in 75 minutes. So you have to adapt, overcome this space motion sickness syndromes in the beginning. You have an adaptation of your human body. The fluid in your body shifts. So here on the ground, basically, when I stand here, I'm in an equilibrium. My fluid sinks down to the bottom, like to my feet, and my heart pumps and makes sure that the liquid comes up again, so that the end product is what you see now. It's an equilibrium. When you think of grandmother or grandfather back home, very often they have swollen feet, like a lot of water in down there. It's because gravity works, but the heart is a bit weaker. So now imagine me being the opposite of grandmother in space. My heart works, but gravity doesn't work. So all the liquid is pumped up, and I have a lot of liquid in my upper body, my upper torso. So we call it puffy face, because my face is a bit thicker. Maybe you've seen it in the video clips. I had exactly the same weight that I have today, but just more liquid in my face, and we call it also chicken legs. The legs are absolutely thin. So when you do the cycling, this is very strenuous, because it feels like you have not the muscle power in your legs. And here on the ground, I used to push when I cycle, but in space, pushing, you need to pull up. the pedals. And so it's bizarre. I feel it's much harder to cycle in space than it is here. Yeah. But you're faster, you're 28,000 kilometers. The fluid shift in your body, it creates headache in the beginning. Then your body realizes, okay, I have too much fluid in my head, and it triggers some signals, and so you need to pee a lot. You get rid of the fluid, and then you have too much. You lose too much water, and the body realizes, okay, my blood is too thick. Now the body reacts again and starts shedding blood cells. So you basically bleed without bleeding. You lose 1 liter of blood while you're in space. And so a lot goes on in the human body. The immune system slows down. It's not as active as before. A lot of the fluid that you have in your upper body, it also, you have a feeling that you're congested. You don't smell well, which is positive because we don't have a shower. But it's also negative because the food tastes stale. And the increased pressure in your brain also squashes the optical nerve. And so your vision gets impaired. And then you have a kind of a shift. Everybody of us gets like several glasses, a pair of glasses. So for reading and also for long distance, because you never know how strong the impact is.
You talked there about some of the physical challenges. I'm thinking, you mentioned your dreams. One was to sit in the rocket, one was to do the spacewalk, and the other was to look back out from space at Earth. I just wonder, in terms of your perspective around looking back at Earth, did that change as a result of your time in space?
Yeah, so it's nothing beats the view from the ISS. So we have this wonderful place which is called Cupola. It's our window down to planet Earth. And we only have windows towards planet Earth. We don't have windows, or like only in the Russian side, a very small window where I can look up into the night sky. But looking down planet Earth, it's such a beautiful place, such a peaceful place also, and we astronauts, we love being there, hanging out in our spare time. And up there from space, you don't see any borders. What you see is like the colors of planet Earth: blue for the oceans, or the sky blue. Or well, you look into the sky and you think like the sky is blue. No, it's the sky is black. The universe is black. It's just you look down and you see like it's the atmosphere which has this blue glow. And then you see the rainforest, dark green. You see a lighter green area, which is the agricultural areas. When you fly over the rainforest in Brazil, you very often see huge columns of smoke when people burn down the rainforest to get more area for agriculture. These are the sad moments. Then you continue your flight, and you fly across Europe during the night, for example. You see all the cities completely nicely lit, and it looks so beautiful and peaceful. And then comes an area which is pitch dark. It's over Russia, behind Moscow. There's not a lot of cities, not a lot of humans being there. And then you arrive close to Korea, and suddenly you see Seoul. Seoul is, during the night, it's so brightly lit. And you think north of Seoul there should be light, but it looks like South Korea is an island, but it's only a peninsula. And you look down, it's like, where's North Korea? There is no North Korea in the night. There is literally no light. There's nothing. And you realize life in this country must be so bizarre, must be so different from the life that we take for granted. And then you continue your flight, and then happened February 2022. And I fly over Europe, and I look down, and I was like, Jesus, what's going on here? Suddenly, there was a country that was brightly lit, like the UK, like Germany, like France, and suddenly turned into North Korea, like for me, went dark. There was a country disappeared, literally disappeared. There was a black spot in the middle of Europe. That was Ukraine. And these are moments when you really think like, what are we doing? What are we doing here? It's, as an astronaut, you learn we can only fly the spacecraft, our spacecraft, if we act as a team. If we work as a team, we can solve any problem. And then you look at planet Earth and you think like, this is spaceship Earth. This is just the biggest spaceship. And we can probably only solve all the issues that we have on our spaceship if we act together. And what are we doing? We start fighting wars.
And of course, on the ISS, you were also there with colleagues from other countries, including Russia as well. Just tell us about the sort of collaboration that you had with those colleagues and how you interacted with them, particularly in light of what you've just said, where there are maybe challenges as well.
Yeah, so when you're up there in the space station, you learn that you have to trust each other. You cannot fly up there and have only semi-trust or no trust in your colleagues, because there are situations where you need to react quickly, and you need to react exactly as you have trained. There might be a fire, and we had 4 fire alarms while I was up there in the space station, or all false fire alarms, luckily. Sometimes there's just dust that gets into the sensors and it triggers the alarm, but you never know until you have checked all the systems that there's really no fire. There's also moments when you're flying towards space debris. And then usually you do a debris avoidance maneuver, you just to get out of the way of the object that's flying towards you. And they also, as a team, you need to act as one team. I was also supposed to do a spacewalk with a Russian colleague. Yeah. And so literally when you're out there, there's only one person who can save your life whenever you're in trouble. And you know that I'm a spacewalker troublemaker. Yeah. So you need to have trust. And I feel like the people that I was in space with, they are not only colleagues, they are friends, they're my space family. And when the Ukraine war started, we had to address this question. So I went over and said, like, guys, how do you see the situation down there? And how shall we now proceed up here in space? And my colleagues said, we're against war like you are. It's space, like wars are no solution to no problem. And we here in space, we will keep on working as we did before. So we stayed good friends, and that's essential. And the ISS is the only international cooperation that we could protect against the impact. That we stopped all other international cooperation with Russia except of the International Space Station. And I think that's good that we keep it going, because there will be a time when the war is over, and then we need to have again science to build bridges and to work internationally.
Absolutely, that's so powerful. And I'm conscious of time. I want to make sure we do get some of the questions from the audience as well, but perhaps I can finish my questions just with taking us back down to Earth. You splashed down in the Gulf of Mexico at 4:43 a.m. on Friday the 6th of May. What did it feel like to return to Earth, and what challenges have you faced since you've been back on Earth as well?
Yeah, so I would have loved to stay longer up there in space, but obviously it all depends on who you're with. And I had a fabulous crew. So we became a space family. And so when we flew back, you saw it that we splashed down in the ocean there. That looks like a massive impact, but it was less than 30 kilometers per hour. So it's actually quite soft compared to all the journey that you had before. Because in the beginning, you have a rocket that accelerates you in 10 minutes up to 28,000 kilometers per hour. On the way back, you need to shed all this velocity. You need to slow down to 30 kilometers per hour. And you do it by surfing across the atmosphere. So we have a heat shield, and that creates friction. Basically what you do on the motorway when you open your window and you put your hand out, you feel already that there's a lot of wind drag. And now multiply this with a few thousands. So our heat shield heats up locally up to, I believe, 1900 degrees Celsius. So if there's no heat shield, you would be fried, you would be cooked, and it would not be a nice day. And in order to avoid that, the heat shield burns through, this capsule like changes direction. So it tilts over 45 degrees and 45 degrees. And this is so bizarre. You return into Earth, you feel the gravity pulling up again, and up to 4 to 5 Gs as during the launch. And then all these sudden movements, and it's a wild ride. And around your space capsule, there are flames everywhere, and you see sparks passing by of pieces of the heat shield that burns off, and you're inside a plasma. So it's a freaky ride back home. Luckily, nobody has told me all these details before, so I might have changed my opinion, not have become an astronaut, but that's the wildest part of the entire journey. Once you splash down, you're safe, but then your body needs to readapt again to gravity. As I said before, the fluid shift, so now we're back in gravity, so the fluid shift reverses and all the fluid goes down and you have not enough fluid in your brain, so you tend to, you could collapse. That's why we usually don't stand up. So they want to keep us in a seated position. We get infusion of liquids, and then we do 3 weeks of rehabilitation phase, where you train again all the muscles that you have not used for 6 months.
And what was it like having that first bit of food back on Earth?
Oh, it was marvelous. Yeah, so we don't have any fresh food up there. Only when a cargo supply mission comes, but then you get like 4 bananas for 6 astronauts. So on the way back, I ate 2 fruit platters in one go, just for myself.
I think you'll agree. We could talk for hours about the experiences that Matthias has shared, but like I said, I'm really keen just to get to some of these questions from you, the audience, as well. So if we'll do a few quick fire questions, if that's okay. Perfect. So just to kick us off, we have a question from Vivian Walter-Barron, who graduated last year in complex particle products and processes. And he asked a question which I think you addressed slightly, but can you just describe the smell of space?
Yeah, so there's 2 parts of it. Like one is like the smelly guys inside the space station, and the other is like the space station itself, and maybe also like space outside. Mm-hmm. So to start off with the space station, a good friend of mine, my mentor, Reinhold Ewald, he's an astronaut. He flew to the Mir space station, and so when I was elected astronaut, he gave me a small German flag that he had on the Mir space station. I said, okay, here you have a space-flown item, and I was super proud, and I smelled on it, and I thought oh, Jesus, it was so smelly, so stinky, so horrible. I thought, if that's the smell inside the space station, I would throw up all day. So horrible. And I didn't, in my mind, this was fixed and said, a space station stinks like hell. Yeah. So I never asked this question to my colleagues. Does it really smell up there? Yeah. And when I arrived in the space station, it was such a nice surprise. It's clean air. It's like in a clean room. Literally, the space station is like a clean room with the air filtering, the HEPA filters. So it smells like in a clean room, and it's very easy to tolerate. So that was good. The astronauts being smelly. Basically we can wash ourselves. There's no shower, and so everybody smells more or less like the same. It's okay because there's we do sports, and then after the sports you have your hygiene, and that's fine. The clothing, we don't have a washing machine, so you wear the clothes 3 days for the underwear, a t-shirt a week, and then you trash it and you get new stuff. And now the smell of space on the outside, and I guess that was probably the question. A surface that has been exposed to the vacuum. Probably it's not purest vacuum. There is kind of atomic oxygen, and then so there is something that reacts with the surfaces. And whenever we open the hatch and we have now a surface that has been to the outside, suddenly in the inside, it smells like a burnt surface. When you have a metro driving into the station and braking, you get this smell, like the burnt brakes. That's more or less like space, how space smells. Yeah. But it's only for a few seconds, and then it disappears.
Yeah. You mentioned a little bit about food when you were back on Earth, but Rachel Watson, who's a food science and nutrition graduate from 2012, would like to know a little bit more about the diet when you were aboard the ISS. And she asks, has space food progressed? And what was your favourite meal? I think, and was the Christmas meal part of this favourite meal is a question that I'd like to know the answer to as well.
Yeah, so has space food progressed compared to what? So probably she's referring to the stuff that they eat, like in tubes and dehydrated stuff. So I would say it has improved, but still there's a long way to go. So you have dehydrated stuff and you add water and you let it sit for a couple of minutes, or you put it into an oven. Well, it's not really an oven, it's like a heating device that heats it up to 60 degrees. And then you can eat hot, rehydrated vegetables or other stuff. You also have pre-cooked meals that are in pouches, and you just need to warm them up in the same device, and you rip the pouch open, and then you have a spoon. That's all you need. We don't have any other cutlery in space. Oh, we have, but we don't use. So you have a spoon and you eat it out of the pouch. And we have cans. So in the old days, the astronauts complained that the food tastes stale, and it's because you have this fluid shift and you feel congested. So they added a lot of salt to the dishes. But then they figured out salt in the food isn't good. It's not good for the blood pressure, but it's also not good because you lose bone mass in space. So the elder people might know that osteoporosis, elder women have this issue, also elder men, above 80, I believe, it's getting a severe topic. So astronauts suffer the same disease, but 30 times faster. So if I don't do any sports in space, in my 6 months, my bones age 15 years.
Wow.
So that's not good.
Yeah.
So, and nutrition is an important factor to it. So now we have learned no salty food, but then we balance the lack of flavor by adding a lot of chili sauce. So
excellent.
So you don't fly to space because it tastes good up there.
No.
You fly to space for other reasons.
Our question takes a slightly morbid turn now, as Lisa Harvey, who's a BSc chemistry graduate from 1995, asks, my husband and I are both paramedics. What would the procedure be if one of your colleagues died in space?
Yeah, so I also trained as a paramedic before starting my university studies. We have a procedure up there, but we actually never briefed in detail, because when somebody is dead, then we have all the time. We have crew surgeons online all the time, so they would walk us through the procedure. I guess we have body bags up there. I don't exactly know. I believe we would fly back the body, but I couldn't tell you. What we do train a lot is like how to avoid that somebody dies. And yeah. So, for example, you learn how to do CPR. Yep. I believe everybody of you have learned it. But imagine now in zero gravity, you're floating. How do you want to push? Like put some pressure on the chest of another body. Yeah. Well, it's like we do it upside down. You have the feet on the roof, and you push with your hand down. And that's how we do CPR in space. And then also, for the paramedics, it's probably standard. But for me, when I learned it, it looked quite violent. Usually when you go to the doctor and you need an infusion, he or she takes your arm and puts a needle inside your arm. But with the fluid shift in space, that doesn't work. And so we kind of, we do military kind of stuff. So we have a device, which is kind of a needle that gets hammered into your tibia. This is tibia? Yeah, I think, yeah. Yeah, so this is like bang, you shoot it in there, and then you get the infusion into the bones.
Wow.
It's pretty violent. But we haven't applied this so far. Hopefully we will not.
Thank you. We've got a question from a graduate who asks, what's the colour of the sun when you see it from outside the atmosphere?
It's the same. It's the same. Yeah.
There we go. That's a nice, easy question to answer.
And you see it like when it disappears behind the atmosphere, then you also get the nice red colors and all this stuff.
You mentioned looking out at Earth. One of our current students asked, what did you find more beautiful, seeing Earth's landscapes up close here on Earth or seeing the whole planet from space?
I love seeing both, and I never saw the entire planet in one go. Yeah. So, we fly in space, but we only fly in 400 kilometers altitude. So we don't have the full view of planet Earth. So you see more or less like an area of 5,000 kilometers diameter. So when I fly over Germany, I never flew over Leeds because we don't get that far north. So when I fly over Germany, on the left side I see southern Spain and Africa, and on the right-hand side I see Moscow, all in one view. And it's beautiful. So the furthest north that we fly is actually London. So just around London we just fly back down south. The inclination of the ISS is 51.7 degrees. So that's the highest latitude that we get to. So I've never seen the poles from space.
We've just got time for a couple more. I'm going to sneak one in just because I think it would be of interest to the audience here, just around the future of space. I know your ambition is to return to space one day. You talked a little bit earlier about the moon. Just tell us, do you think we will land astronauts back on the moon in your lifetime?
Oh, definitely. It's like, I hope I live that long, yeah. So basically, at the moment for human spaceflight, we have 3 destinations that we want to fly to. The first one is like low Earth orbit. Low Earth orbit is 400 kilometers of altitude, and there we have the International Space Station. And once it gets deorbited in 2030, we will have hopefully a follow-on new station, or even several stations. Now we even have the Chinese space station flying there. It's more or less the same altitude, a few kilometers plus or minus. And we will continue flying in low Earth orbit because there we can do research and science in zero gravity. The next step will bring us closer to the moon. And when I say closer to the moon, it means not yet to the surface of the moon, because we're currently building a new space station, a tiny one compared to the ISS. There's only like 2 or 3 modules where you can be on the inside, and some additional modules for just to make that it functions. It will fly around the moon, and this will be a stepping stone for us. So we can fly to that station, and from there we can descend to the surface of the moon. But we also can do another type of science on this moon station outside of the Earth's magnetic field. This station is called Lunar Gateway, and Artemis 3 is supposed, like Artemis 1 was an unmanned mission flying around the moon, checking out the system. Artemis 2 will see the first human beings flying around the moon, not yet landing. Artemis 3 is supposed to land on the moon. But for landing, you need like a certain type of hardware, which is first of all the rocket that brings you there. And the rocket to fly to the moon is much, much bigger and more powerful than a rocket that brings you to the ISS. Then you need a capsule with a much better heat shield, because when you come back, you have 40,000 kilometers per hour, not only 28. So the heat shield needs to be way more resistant. And that's a current issue because the heat shield that they tested in Artemis 1, it's not yet there. So NASA doesn't want to put astronauts in the same capsule with that heat shield. And Artemis 3 then going to land, you need a lander. And the lander is being built by SpaceX. And maybe you followed along the Starship. That's the huge rocket that flies up and explodes. As soon as it stops exploding, we might consider putting humans on there.
Just off the back of that, I'll ask an additional question, just around the role of private business and in the future of spacecraft as well. You flew on a SpaceX craft, as you explained earlier, but what role do you see in the future, and how we see that relationship developing?
Yeah, so private companies, especially SpaceX, they are really, really fast moving and like super, I would say like super focused and making spaceflight open to many more people. In the past, everything was handled by agencies, so NASA or ESA or the Japanese Space Agency. And the Space Agency, they take less risk, and probably they need to talk more and have more politics involved. And a private company can actually say, like, okay, what's the business? And now we do the stuff. And so 20 years ago, ESA, the European Space Agency, and when I say European, means like this still includes the UK, because ESA has nothing to do with the European Union. And after Brexit, the UK actually doubled the contribution to ESA. So you guys are fully European regarding space, which is a good thing. Together we can do stuff that nobody of us can do by himself. And so space agencies, they have their policies and their politics and all this stuff, and SpaceX is moving super fast. On Sunday, we will have hopefully the next launch of this Starship by Elon Musk. Hopefully they will manage to land that one. And I think that rocket that he's currently developing, it will be an absolutely game changer. So at the moment, we have astronauts flying in capsules. Tim Peake flew in a Russian Soyuz capsule. There's place for 3. I flew in the SpaceX Dragon. There's place for 4. That thing that they are going to build now, it has room for 100 astronauts. Wow. So imagine, it's like we're changing from a Cessna to an Airbus A320. Yeah. That is now the transition, and very few people have the grasp of how much change this will bring to space. It's a good thing, but it's also a little bit of a scary thing if we in Europe don't get our act together. Yeah. 20 years ago, Europe was the leader in commercial space transportation. So we had per year around 15 launches, and we brought all the satellites up there because we were much cheaper than the American institutional launches. Now SpaceX has completely taken over. Last year they had 100 launches. We in Europe, we had 3. Just to show you. 85% of all the mass that was transported into space was done by SpaceX. 15% Russia, China, India, and Europe. So and to give you the picture, like how dominating they are. And with the new Starship, this will even go like it will be more severe. So I think we in Europe, we need to take action. There are other spacefaring nations by now that can do stuff that we can only dream of. So in the past, it was Russia. They flew to space, they had the first space station, they have their rocket, their capsule, they manage everything. Then NASA did the same. Now China, they have their own rockets, their own astronauts, their own capsule, their own space station. Now India will fly in 2 years. Their astronauts in their capsule, in their rocket, and they're already talking about building their own space station. Where's Europe? Where's Europe? We are hitchhikers. We hitch a ride with the Russians or with the Americans. And now with the global politics changing, you see the US elections upcoming. Depending on who will win this election, international cooperation will be more challenging. And with space becoming more and more commercial, also the way we are doing business in space, which is a barter system. Basically, when you pay tax and your money is invested by your government to do something in space, it means like for Germany, for example, Germany invests 1 billion euro per year for space, and they transfer this money to ESA. ESA sends exactly 1 billion euros back to German industry to build space hardware. And this space hardware is then given to NASA, and in exchange, we can fly to space and do experiments in space. So this is what we call a barter element. The money doesn't burn up during the launch. The money actually goes into your economy. So your British pounds, 1-to-1, end up in your economy. Nothing goes to France or to Germany, and the other way around for our taxpayers' money. And the politicians love this because it's fair, it's just, and it gets a lot of support. But now with the commercial space age, the you're suddenly offering a hardware to a company, and the company says, no, we want to have your money. We don't want to have your hardware. So how are we going to do business in the future? And how do we keep our money in our country to develop expertise and knowledge? Because that is, in the end, what we need. So it'll be challenging, but it will be exciting.
Thank you. I said before, I think we could spend hours, couldn't we, just listening to Matthias on these subjects, but we're so grateful for all your time and generously giving it this evening. I'll finish, if I may, by a question that's from Tobias Harvey, age 6, who's the son of Hannah Harvey, who's one of our international relations graduates from 2006. And Tobias asks, I would like to go into space one day. How can I make this happen?
Yes, so there's no guarantee that you can become an astronaut, even if you plan it really hard. There's so much luck and chance involved into it. But I believe it's you need to keep dreaming, because if you don't have a dream, you can never fulfill a dream. Do what you like to do what you're best at, and do it with all your heart, and maybe it comes true.
Thanks, Matthias. Can you just join me in thanking Matthias for his time this evening?
Thank you. Thank you very much.
Wow. I could carry on listening for hours. I think we all could. Thank you so much, Matthias and Mark, for entertaining us with your conversation for this evening session. I've been thrilled, and I know that the audience online and in person will have also. I think I've also recruited you now for my next expedition to Antarctica. If you haven't seen Antarctica from space from the ISS, then we've got to get you there in person.
Excellent. It would be good. Actually, it also makes sense because some of my colleagues go to Antarctica to collect meteorites.
Absolutely. There's so much you can do in Antarctica. So I think from my perspective, reflecting on everything you've said, your journey seems to have all the hallmarks of every great adventure out there. You've showed great skill through your science, both in industry and also up in space. You've showed huge determination in overcoming obstacles when even the impossible felt like it wasn't going to happen for you. And you've had ambitious hope at every step of the way, knowing that if you can just hold that vision, you'll be able to get through and deliver on your dream. What an inspiration. Yorkshire is proud to have you here today and to have had you study with us. And Leeds is thrilled to have you in our alumni network. It's been an absolute pleasure. Thank you, Matthias.
Thank you very much. Thank you. Very nice.
So I'd like to wrap up by thanking all of you in the audience for your time this evening. It's great for us to host you on campus, and I hope that this event will mean that you'll come back for more next time. For those of you watching online, thank you for joining us. We hope to host you in person next time, and we hope you've enjoyed your evening in the comfort of your living room, maybe. We have drinks in the foyer, and so for those of you that are here, please do stay for one more before you head off home. And Space Hub Yorkshire, which is our regional space cluster, also has a stand in the foyer, so please do stop by to find out what we're doing in space here in Yorkshire locally. So thank you to everyone, and have a safe journey home.